Okay, now I'm going to talk about what happened in the field, what goes on in the field with the surveyors. So before I jump into that and go a million miles an hour again, somebody tell me anything at all, any questions, any comments? Yes, sir.
Yeah, you mentioned a couple of times that you're using the email system to notify people of changes, and I appreciate that, but most people in the room are like, getting a couple hundred emails a day is typical. Is there some other way that you've got for your people to see when things are moving? I'm going back to your map-based view. You had this red green light for going to the right-of-way, the parcel. Do you have something else like that? Like this part of the project in yellow has changed a lot.
Yes. And at the very end here, what I'm going to show is the GIS that we've built. And that's exactly where that happens. In other words, you're absolutely right. The email by itself isn't good enough. And I agree with you. What happens in the database is that not only do colors change, but also notes appear and tooltips, if everyone knows what I mean by a tooltip. Tooltips appear as things change. This is vital. You're absolutely right. The reason for the emails is as a backup to that, because people aren't necessarily looking right at the instant that they need to know that something happened. I don't want them to go do something and then, oh God, I didn't see this, you know, kind of thing. I'll be honest with you too. I'd rather replace the email system. I would rather do that. Okay. Anything else? Yes.
For this email notification, excuse me, and posting notes, is that all automated and triggered within the database, or is that a process that people would have to do?
Okay. The email is triggered automatically. The posting to the database or to the GIS has to go through the DBA, because he will get a notice that something has changed. But what I don't want to have happen is that being untouched by human hands, because if something changes, there has to be some intelligence as to whether this is correct. Are we getting a conflict? Is somebody saying this and somebody else saying that? This kind of thing has to be worked out. That's why I have a person in that loop. Good questions. Thank you so much. Please, anything else? Okay, I'll buzz on here, and please jump in at any point. Okay, we've got the guys out in the field. They're collecting this. Are they doing it sub-meter? No. Are they grade? Yes. Isn't that expensive? Doesn't that take too long? Absolutely not. Let me explain something that I'm passionate about. There is no reason at all in terms of efficient cost today, now, to say, well, we don't need the survey grade, we'll use the sub-meter, because it's faster, it's easier, it's cheaper. And I'll be happy to defend that statement, believe me. Now, it used to be, not very long ago, that's true. It was expensive, it was slow, it was cumbersome, it was complicated. That's not true anymore. And I'm going to try to explain part of the reason why. In the vicinity that we're working, in Fort Worth, Dallas, there is what's known as a real-time network, RTN. Some people call it a VRS, virtual reference station, virtual reference station. That's actually a brand name by Trimble. You can call it a real-time network. Basically, what it means is that there are base stations. Okay? These are continuously operating reference stations. They're constantly tracking the GPS. Constellation. Their information, because they know where they are, goes back to a data control center. All of this happens out of our hands. We're not doing this. This is being handled by other folks. That data control center takes all of this information from all of these base stations and actually creates a model of the errors, the biases in that vicinity. Then, this rover, just as this gentleman has here, goes out into the field by itself without a base station, just one receiver. He's got a cell phone attached to it. So what he does is he goes out, he gets a point within centimeters, XYZ, like that. The reason is because all of the correction signals come from the data control center to his receiver in real time. All right, now, you might be saying to me, well, that's fine, good, I'm happy with that. Why? Why do I need that? Why can I be out there with an XH or an XT or a Garmin or a Magellan or whatever it is, and because we're dealing with property corners. We can't do property corners that way. We have to have this kind of accuracy. Now, we could do the topography in terms of the fences and the creek crossings and the etc. with submeter. We could, yes. But why? We don't need to. We've already got this. So this is how we're collecting our data. And the other thing is this data logger. I'm going to be talking about that data logger. The thing, of course, is an extraordinarily flexible computer. Now, it used to be that this was done with RTK. How am I doing on time?
You're okay. We got about at least 10 minutes.
All right, I'm gonna go as fast as I can. RTK was great. It used to be the way to go. Not anymore. This is the virtual real-time network. These are all base stations in the Fort Worth area. Okay, there they are again. I'm going to zoom through these. This is my idea that I was just saying, that the NMEA string goes to the data center and the RTCM, which is a correction signal, comes back. And this is why we can get centimeter level positioning. You don't have to do your own control network. It's unnecessary. One of the things that this allows you to do is get redundancy on all of your positions from at least 3 control stations. And I would love to talk about that, but I will not bore you with it. If somebody wants to talk about that, please, just let me know. Single GPS receiver does the job. This is my green light, red light that I was talking about right there. The last thing we want is that guy. I didn't say you could be here. Get off my land. The other aspect that we've done here is we're using state plane coordinates, but we've moved them up to ground. Now, I have to tell everybody in the room I'm no fan of that. I can go on and on about that too. But in this case, we did. We built 5 zones. And you notice in the middle of each one of these zones is a combination factor. And what that means is we've got it up to ground, but we've got it arranged so that as you go from zone to zone across one of these zone boundaries, you're not going to get a discrepancy of more than 1/10 of a foot, at worst. So that's why we've done it this way, so that the distances on the ground will match the distances inversed by the coordinates. This is, of course, important to people who are building pipes. They like to know how long they are, don't they? Okay, and we have a specific data dictionary, which is based on pods. I'm not going to spend a lot of time on this. I think you all know what I'm doing here. These are basically aspects of the data dictionary that come directly out of the data model. Nothing particularly unusual about that. And then, of course, the right-of-way acquisition happens from the database. This is, again, an example of an exhibit. Now, this table, bunch of numbers, is just an example of all of the data collected in the field. We have a point number, northing, easting, elevation, point code. Here's a concatenated string. This code, which is this long thing, is the way that you can actually access each individual point in the database just by clicking on it. And there's one unique point for every code. There's no duplication. Date and time and the attribute of what the thing is. Now, all of this information comes into, I'm going through Blue Sky here, comes into our database automatically. In other words, the data comes from the field, it's downloaded automatically along with all of its attributes in AutoCAD. And it also goes into the database, of course. Now, this is that long, unique identifier. Here's the northing and the easting, the point number, what it is, its power, it's a guy anchor. All of that information is there.